In this video, we will introduce buffers direct within the Java programming language. NIO supports a type of byte buffer usually known as a direct buffer. Direct buffers can essentially be used like any other byte buffer and are implemented as a byte buffer subclass, but have the property that their underlying memory is allocated outside the Java heap. Some notes about direct buffers from the JDK documentation are in order. Quote, "It is therefore recommended that direct buffers be allocated primarily for large non-lived buffers that are subject to the underlying system's native I/O operations. In general, it is best to allocate direct buffers only when they yield a measurable gain in program performance." Close quote. Let's implement an example of using direct buffers. First, let's make an array of ints so we can have values to work with. We'll have the values 1, 2, and 3. Then we're going to set up an array buffer, but we won't initialize it yet. We'll use a byte buffer and we'll allocate its size to 64. Now we're going to set the byte order to the native byte order of the underlying platform for portable program. We're going to be using the static method native order. Now we're going to convert this buffer into an int buffer. Using the asIntBuffer method. And we're going to put our values in this int buffer. Now we're going to move the position to 0. And we're going to see what this value is. So we're going to print it to the console. So here we're going to get the value. Using its index. Now let's see our output by running our program. Right-click on the source, run as Java application, and we can see that the location of 1 is read at the given index. Buffers have the following properties. Once allocated, their memory address is fixed for the lifetime of the buffer. Because their address is fixed, the kernel can safely access them directly, and hence direct buffers can be used more efficiently in I/O operations. In some cases, accessing them from Java can be more efficient. There's potentially less overhead in looking up the memory address and/or other housekeeping required before accessing a Java object. See the example NIO buffer performance measurements made in Hotspot under Windows. Via the Java native interface, you can actually set the address arbitrarily if required. This concludes our discussion of buffers direct in Java.